Hello friends, today we are going to study on the topic cells in series and in parallel. Cells are said to be connected in series when they are joined end to end so that the same quantity of electricity must flow through each cell. There are some rules for a series combination of cells. The equivalent EMF of series of combinations of n number of cells is equal to the sum of their individual EMFs. The equivalent internal resistance of a series combination of n number of cells is equal to the sum of their individual resistance. The equivalent EMF of n number of cells in series is given by E1 plus E2 plus E3 to n number up to n terms is equal to n. Equivalent internal resistance of n cells in series is given by Req is equal to R1 plus R2 up to n terms is equal to nR. Total resistance is equal to number of cells plus number of cells into internal resistance plus external resistance. Current in the resistance R is given by I is equal to Ne divided by R plus nR. N represents number of cells plus cell EMF divided by external resistance plus number of cells into internal resistance. That is given here, and there are three cases here. Case 1, when R is much lesser than number of cells into internal resistance. I is equal to E divided by internal resistance is equal to current due to single cell. The case 2, when R is much greater than nR. I is equal to Ne divided by R is equal to n times the current due to a single cell. The case 3 is when cells are of different EMFs and internal resistance. I is equal to I1 plus I2 to n terms divided by external resistance plus R1 plus R2 to the n terms. Cells in parallel. Cells are connected in parallel when they are joined positive to positive and negative to negative such that the current is divided between the cells. The rules for parallel combination of cells. The equivalent EMF of a parallel combination of cell of same EMF is equal to the EMF of one cell. The reciprocal of equivalent internal resistance of parallel combination of cells is equal to the sum of reciprocal of internal resistance of each cell. 1 by resistance in parallel is equal to 1 by R1 plus 1 by R2 up to n number of terms, or it can also be given by reciprocal, that is Rp is equal to R by m number of terms. External resistance and internal resistance in parallel are in series so that the total resistance in the circuit is equal to R plus external resistance plus internal resistance by n number of terms. In parallel combination of identical cells, the effective EMF in the circuit is equal to the EMF due to a single cell, because in this combination only the size of electrodes increases but not the EMF. Current in the resistance R is given by I is equal to E divided by R external resistance plus internal resistance by n number of terms. In parallel combination we also see three cases where n is much lesser than R by m. Then I is equal to E by external resistance is equal to current due to single cell. Case 2, when R is much lesser than R by m, then I is equal to E divided by internal resistance divided by n number of terms is equal to n E divided by m. That is equal to n times the current due to a single cell. Case 3, when cells are of different EMF and the different internal resistance. I is equal to E divided by external resistance plus internal resistance. That is equal to 1 by internal resistance is equal to 1 by R1 plus 1 by R2 to the n terms. Let us see two questions based on series and parallel combination on finding the equivalent resistance. First, let us see a question based on series combination to find the equivalent resistance. Batteries of 10 volt and 5 volt are connected in series such that their EMF point is in same direction. The internal resistance of two batteries are 2 and 10 ohms respectively. Find the equivalent resistance. So batteries are given of and the resistance is given.
First identify the symbol, whether it is E1 or E2 or V1 or V2, R1 or R2, represent all the parameters by symbol, so that it will be very useful and very easy for you to select the suitable formula. Always you must write the given. So what are the parameters given in terms of expressions? Okay.
So
in terms of symbols and its values.
E1 is 10 volt and E2 is equal to 5 volt as given in the question, and resistance R1 is equal to 2 and R. So EQ is equal to E1 plus E2 when comes. So we are taking
Put plus properly. How they are connected, E1 and E2, whether they are connected in parallel.
Series.
You have to mention that.
Equivalent resistance is asked in the question, so R is equal to R1 plus R2 line terms. R1 is equal to 2 plus R2 is equal to 10. Now there is a second question in which we are going to see.
What is that 12? R equivalent?
Sir?
Mention that. Put it in the box. You have to write both what are given, what are asked.
Yes.
So you have mentioned about given, and what are asked, where you have mentioned that to find out. To find what?
Equivalent resistance.
Equivalent
Resistance.
REQ, and then REQ put question mark is equal to question mark is equal to question mark, and then what else is asked?
That's all. And E.
Is it internal resistance or resistance?
Resistance.
Resistance should be mentioned by capital R only, is it not? Internal resistance will be mentioned by small r. Whether it is internal or external, generally resistance.
Internal resistance.
Huh?
Internal resistance.
That's all.
So there is another question.
Proceed with that. Show me that question. Keep it here. Read the question.
3 batteries of internal resistances 2,4 ohms are connected in parallel. Find out their equivalent resistance. So we are going to find out in parallel. So to find out in parallel,
You can erase and make use of this one. Explain.
Sir, three resistances being given in the question, sir. R1 is equal to 2 ohm, R2 is equal to 2 ohm, and R3 is equal to 2 ohm. They are going to find out R equivalent resistance. So in parallel combination, we use this formula, sir. So 1 by R1 plus 1 by R2 plus 1 by R3 to the inputs. So we are substituting R1 and R2 and R3. So we are getting as 1 by 2 plus 1 by 2 plus 1 by 2. While calculating that, Req is equal to, okay.